A spherical helium balloon has a diameter of 1 meter, a temperature of 27 degrees C, and a pressure of 1 atm. Find the time a helium molecule in the balloon takes to traverse along the diameter of the balloon with its root mean square speed. We use the circle to represent the three-dimensional spherical helium balloon. The diameter of the balloon is the D. Capital D represents the diameter equal to 1 meter. So the question asks, for a helium molecule to traverse along the diameter with the 1 meter length, what is the time required? So to find the time required, the T will be equal to the diameter divided by the VRMS, because now we assume that the speed of this particular helium molecule is equal to the root mean square speed. So that's why we use the distance, diameter D, divided by the VRMS, which is the speed of the helium molecule that we consider. Then we'll get the time T required to traverse along the diameter. Since we already know what is the value of the diameter, that means to find the T, we need to find out first what is the VRMS of the helium molecule in the balloon. We have two formulas to use to find the VRMS. One is in terms of capital M, molar mass, and one is in terms of the small m, which is the mass of one single molecule of helium. Now we can easily recall that the value for the molar mass of helium is 4 grams. With this information, of course, we can also find out what is the mass of a single molecule. But now we choose the easier path, where since we can directly recall that the mass of molar mass of the helium is 4 grams, so now we choose to use this first formula. In this first formula, the capital R is a gas constant 8.31, T is a temperature in Kelvin, so we convert 27 degrees C into 300.15 Kelvin, and the molar mass of the helium molecule is 4 gram. 4 gram per mole. So convert to kg, you get 4 times 10 to the power of -3. So we will get the answer for the VRMS now is 1368 meter per second. So to find the T, now we can take this D as 1 meter, and the VRMS we substitute the value of 1368 meter per second. Then we'll get the value for the T. It is 7.3 times 10 to the power of -4 second, or 0.73 millisecond. So this is the time required for a helium molecule with the speed equal to 1378 meter per second to traverse along the diameters of the balloon. Important reminder for these questions. The VRMS or the root mean square speed, it is an average concept. To find this VRMS, we use this formula. So from this formula, we can know that the value of the VRMS not necessarily same as the speeds of the individual particles in the balloon. But these questions assumes that one of the helium molecule has the speed that the magnitude same as the VRMS. That means it is equal to 1368 meter per second. It does not mean that all the molecules in the balloon have the same speed as the VRMS. But for these questions, we only consider a particular helium molecule where its speed is the same as the VRMS, which is 1368. Then with this speed, what is the time required to traverse along the diameters of the balloon. So please do not confuse between the speed possessed by the individual particles and the VRMS, which is applied to the entire systems of the gas in the balloon. They are not the same.